Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and as always, I'm joined by my brilliant co-host, Victor. Before we dive in, I just want to remind our amazing listeners that if you're enjoying our show, please take a moment to rate us on your favorite podcast platform. Your support means the world to us.
Absolutely, Sheila. And hello, everyone. We're excited to continue our journey through Season 2, where we're exploring core hole-punch technologies. Today, we're diving deeper into Chapter 2, Hyperswarm Networking, specifically focusing on peer discovery in Hyperswarm.
That's right, Victor. And to kick things off, I've got a brain teaser for our listeners. Here's the quiz question. In a decentralized network like Hyperswarm, what's the primary challenge that peer discovery solves? Is it A, encrypting data, B, finding other nodes to connect with, or C, storing large files? Think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's a good one, Sheila. It really gets to the heart of what we're discussing today. Listeners, while you ponder that question, let me add that each of those options is important in decentralized systems, but one is particularly crucial for peer discovery. Keep that in mind as we explore the topic.
Great point, Victor. Now, before we dive in, could you give us a quick refresher on what we mean by peer discovery in the context of Hyperswarm?
Certainly. Peer discovery is the process by which nodes in a decentralized network find and connect with each other. In Hyperswarm, it's like a cosmic dance where peers are constantly looking for partners to share information and resources with. Without effective peer discovery, a decentralized network would be like a bunch of isolated islands with no bridges between them.
That's a vivid analogy. So, how does Hyperswarm approach this cosmic dance of peer discovery?
Great question. Hyperswarm primarily uses two key mechanisms for peer discovery: distributed hash tables, DHTs, and topic-based networking. Let's start with DHTs. A DHT is like a decentralized phonebook that all peers contribute to and can look up information from.
Interesting. So, if DHTs are like phonebooks, how do peers use them to find each other in Hyperswarm?
Well, in Hyperswarm, when a peer wants to join the network, it generates a unique ID and announces its presence by storing its contact information, like IP address and port, in the DHT. Other peers can then look up this information to connect. It's similar to adding your number to a phone book and others being able to find you.
That makes sense. But Victor, I'm curious. How does Hyperswarm ensure that this phone book is distributed and not centralized?
Excellent question. Hyperswarm uses a variant of the Kademlia DHT algorithm. In this system, each peer is responsible for storing a portion of the network's information. The DHT is divided into sections, and peers are assigned to manage specific sections based on their ID. This ensures that the information is spread across the network, making it resilient and truly decentralized.
Fascinating. Now, you mentioned topic-based networking earlier. How does that fit into peer discovery in Hyperswarm?
Topic-based networking is another key feature of Hyperswarm's peer discovery. Imagine it like tuning into a specific radio frequency. Peers can join or leave topics, which are essentially groups or channels. When a peer wants to find others interested in a particular subject or service, it can search for or announce itself under a specific topic.
That sounds efficient. So, if I understand correctly, peers can find each other not just by individual IDs, but also by shared interests or functionalities.
Exactly right, Sheila. This makes it much easier for peers to find relevant connections quickly. For example, in a decentralized file-sharing application built on Hyperswarm, peers looking to share music files could join a music topic, making it easier for them to find each other.
I see. But Victor, I can't help but wonder about potential challenges. What if a malicious peer tries to flood a topic or manipulate the DHT?
That's a critical point, Sheila. Hyperswarm implements several security measures to mitigate such risks. For instance, it uses cryptographic signatures to verify peer identities and employs rate limiting to prevent flooding attacks. Additionally, the distributed nature of the DHT makes it resistant to single points of failure or manipulation.
Thanks for clarifying that, Victor. Now, how does Hyperswarm's peer discovery compare to other systems? Are there any unique advantages?
Great question. Compared to centralized discovery systems, Hyperswarm's approach is more resilient and scalable. Unlike systems that rely on a central server for peer lists, Hyperswarm can continue functioning even if some peers go offline. Its topic-based approach also allows for more efficient and relevant connections compared to random peer sampling used in some other P2P systems.
That's really impressive. As we wrap up, could you share a best practice or tip for developers working with Hyperswarm's peer discovery?
Absolutely. One key tip is to carefully choose and manage your topics. While it's tempting to create very specific topics, overly narrow topics can lead to fragmentation and difficulty in finding peers. It's often better to use broader topics and implement additional filtering at the application level.
That's great advice, Victor. Now, let's return to our quiz question. The primary challenge that peer discovery solves in a decentralized network like Hyperswarm is B. Finding other nodes to connect with. Victor, would you like to elaborate on why this is so crucial?
Certainly. Finding other nodes to connect with is fundamental to the functioning of any decentralized network. Without effective peer discovery, nodes would be isolated, unable to share data, resources, or participate in the network's activities. It's the foundation that enables all other aspects of decentralized systems to work.
Perfectly explained, Victor. To summarize today's episode, we've learned that Hyperswarm uses a combination of distributed hash tables, DHTs, and topic-based networking for efficient peer discovery. DHTs act as a decentralized directory, while topic-based networking allows peers to find each other based on shared interests or functionalities. This approach offers resilience, scalability, and efficiency in peer discovery.
Excellent summary, Sheila. And remember, listeners, understanding peer discovery is crucial for anyone looking to work with or build decentralized applications. It's the invisible magic that keeps the decentralized web connected.
Absolutely. And on that note, we'd love to hear from you. If you enjoyed this episode or have any questions, please visit crashcasts.com or join our Discord community. Your engagement fuels our passion for sharing knowledge about decentralized technologies. Don't forget to subscribe to the podcast and leave a rating on your preferred platform. Until next time, keep exploring the decentralized world.